Hello my friends, welcome to Instant Electronic channel. This is Uncle Misha and today we're gonna take a look at this Starfrit kitchen scale. The problem is it does not really working. Not sure what happened to it. Well, let me put the battery and I'll show you. It had a bit of a tumble, so probably something wrong. Okay. So it tried to zero itself. It shows nothing. It shows nothing. So clearly there is some sort of problem. So let's together take a look what's going on here and see how this thing works and see if you can repair it. So this is supposed to be pretty simple thing. Doesn't not complicated mechanism, and as you know, all electronic scales that are a budget electronic scale, they work using load cells. So we're gonna take a look what kind of load cell this thing has inside and see if we can repair it. So let's do it together. So it has only looks like it has only a few screws, one here and one right here. So let's just open it up. Looks like we have two more screws right in here. I'm not 100% sure how this is all interconnected, but let me unscrew this using this bolts. Oh wow, that's pretty tight. Wow. Okay, I think it's going. I see. Wow, this cool plate was actually... Can I use it for as 3D printing plate? That's nice. I can think about it. If this thing is broken, I guess I can. Okay, here we are. A very simple construction. Here is the loading cell. Here is some electronic stuff and some... what the heck are these? I don't know. Let me see. So this is the battery. So this is our loading cell. It has 4 wires. So let me also open this one here. This on this side is going to be super simple, I assume. And here we are. So we have a screen, some little controller, probably another controller right under the screen. Yes, there is a blob under the screen, which actually the display controller. This could be what is this? K24C02D. Not sure, but we're gonna check what is this. Obviously there is some crud in here because it obviously was used in the kitchen. There's something for calibration, very interesting. I assume this is calibration because some of the how do you call them? The pads here is shorted, so I assume this is for sort of calibration or some kind of settings. They're missing few things. For example, here is some footprint is missing for U3. It looks like a sort of voltage regulator footprint. Interesting. That's pretty much it. Jumper and voltage regulator circuit. So this is our battery, which says power, and here is wires which are really shittily soldered. Very bad soldering job. Wow, that's just horrible. Yeah, that's pretty much it. Obviously there is a little bit more electronics underneath this display. That's pretty much it. And obviously this display is purposely built because it has switches for if I power it up. Let me find this battery. It has obviously these specific switches, as you saw. Okay. Okay, well, nothing happening with this power load cell. So let me actually measure something, because I already shot the video when I explained how load cell works. Let me here's the reference to that video that's gonna explain how the load cell works, and based on that we're gonna do some measurement here to see what is the problem with this one. Maybe there is a load cell busted itself, or there is a wiring problem of some sort. Okay guys, so I brought here my multimeter and it's powered now. So let's measure some voltages here. Before I actually measure voltage, I explain. So this is essentially my old material when I explain how this load cell works. So here, take a look at the schematic. So we have V in, V out. So this thing essentially measures the voltage differences between V in and V out. When this load cell is balanced, like in this straight condition, V in and V out supposed to be equal. So let's see what we have here. So which one is in and out in this particular case, I do not really know. Doesn't really matter. So we have wrong. So we have supposed to be some voltage here. What's going on? 1.5 volts right here. Okay, so let's measure. It marked as E minus, E plus. Now we're measuring S minus and S plus. So we have nothing, and nothing really changes when I press on it, and when I go back to the E, nothing really changes. So technically we clearly have an issue. Now I have to figure out what is the problem. So problem with load cell, or problem with whatever amplifier or microcontroller is here, which actually does the measurement of those voltages. So for this purpose I would have to unsolder all those wires. So what I've done here, I've unsoldered the load cell, 4 wires from the main controller. So what I'm gonna do, I'm gonna manually try to measure resistances and voltages right here. But before I do that, let me talk about a little bit here. So here is a whetstone bridge. So essentially it's double voltage divider. So I marked, before unsoldering, I marked a contact right here, and also colors of the leads of the load cell. Also, I measure resistances of each, well, resistor or strain gauge right here, or strain resistor which in the load cell. So because of this is voltage divider, so here are the values of the resistors. As you see, they actually quite low the shop. Essentially, I'm wondering why these are different, and I measured them several times. Maybe this is the issue. So these and these supposed to be the same, or at least I mean this and this and this and this supposed to be the same. They're not too far, you know, that's only like 7 ohm difference, and here is like 10 ohm difference, but yeah, they are different. But ideally all those 4 resistors supposed to be equivalent resistance in order to have 0 volt here. So if you apply some voltage right here on excite, this is called excite, and this is I think signal, source signal, I don't know what S stands for. So if you measure here, it's supposed to be 0 volt, because all those 2 voltage divider are balanced, so that's supposed to be a 0 volt right here. Let's measure what we have. So I'm gonna apply 1.5 volts right here. I think this is what I measure right on this excite contacts right there on the board. So it applies 1.5 volts, and let's see what we're gonna have on this S outputs. All right, so for this I have my multimeter. It's gonna be in millivolt range. I think millivolt range is fine here, right? Okay, let me put this multimeter in a way you can see something. And here's my 1.5 volt applied. So it says 0 millivolt, which is, oh, that was pulling stuff around, and that's why it's not showing. Okay, so it says 5.8 millivolt. Negative, that's whatever, that's polarity, doesn't matter, I can just swap it up. So essentially, when we apply, yeah, let's see, it reacts. It's obviously, I thought difference would be a little bit, unless it's 5.8 millivolt. It's really low value. Yes, it reacts. It does. So if I take this one and put it on, yeah, well, 0.1 millivolt difference. I don't know, man. It looks like, so this is heavy screwdriver. Let me try it. Yeah, it's what? Not much of a difference, unless I have to measure microvolts, which I don't have capacity to measure. This is what I can get. This is really strange to me. I really press on it, of course it changes, but I mean, this is probably like, you know, 4 kilos of pressure, 5, something to this extent. This, by the way, the scale is 5 kilogram maximum. So let me see the voltages actually right here, but I think last time I measured it was 1.5 volt. Okay, so now we sort of see that this load cell is kind of working. Like resistances are, so you can measure all these 4 resistances. So if you can measure 4 resistances, there is no break in the wire somewhere. So if, for example, you would have break here and you would measure between black and blue, it'd be like infinity. But I can measure all between you know, red and white, red and blue, black and white, black and blue, all has different values resistances. So load cell probably working fine, unless it damaged in a way that it does not, for example, one of those resistors just unglued, you know, or few of them are unglued from the metal plate they supposed to be stuck on. That's why they react so badly. So if they do not deform in order to change the resistance, they would not work properly. They would act as if they require much more bigger load. So that could be the case, yeah, because they unstuck from this thing. But I visually don't see anything unstuck. So unless it's on the bottom and I don't see it, I may just unscrew. But here on the top, it seems to be pretty solid. So yeah, I don't know what's really going on here. So maybe I'll resolder this thing back to the board and try to do measurements right when it is connected to the board. Alright guys, so what I've done here, I have connected a battery, I have soldered black and red wires, and I'm gonna measure those two on a C, and also disconnected the load cell just to make sure nothing was damaged on the bottom. Looks like everything is fine, and I would like to see, let me power it up, I'd like to see what I'm gonna measure. Okay, I measure 6 millivolt right here, because when it's stabilized, so it's 5.86, it's about right. So now let's load it. Yes, okay, so it definitely does something when I try to load the cell. Okay, so our next step would be put those back on and try to measure. So if it's not gonna work, that clearly there is at least to some degree, clearly there is a problem somewhere in this in this board, because clearly the digital part which shows data is which works with the screen and buttons are working, and maybe we have an issue with the amplifier, maybe we have an issue with some wiring somewhere, so we have to double check all that. Alrighty, so I have soldered the wires back on. Let's power this little guy up and see what's gonna be happening. Okay, nothing happening. Do you even have any like voltage changes? It would be really hard to measure. Somehow like this, and try to Okay, so that still works. So it looks like our voltage or signal changes is not getting through. So now I have to trace where this is going. Let me trace it quickly and we try to measure further down the circuit. Okay, my friends, I did a little bit more of wire tracing and I figure the following. Let me zoom in a little bit and I'll explain you quickly. So here is zoomed in view and I try to peel off this screen a little bit just to understand what's up, what's going on right here. Okay, so blue and white wires, these are the wires where the voltage is gonna be sensed by the microcontroller right here. By the way, this is, I was wondering, if you're wondering what is this is external EEPROM, 2 kilobyte external EEPROM. So it holds the code for this microcontroller right here, and microcontroller is this blob over here. So this that blue wire goes, I don't know if I would be able to show you, goes directly through here capacitor, like probably some here is the capacitor, and it goes straight to the this blob. So yeah, it goes straight to the microcontroller. So the white wire goes through this network of dividers. Probably each is to calibrate or like, because these resistors may have different values, and they're using this dividers right here in order to bring it to something what a microcontroller expect, and hence there is all those jumper pods to connect those resistors. So here we are. So this is dividers. So these white wires goes through this network of dividers and then loops back through these capacitor and resistors, and through so signal is right here through this resistor capacitor right on this pad, and it goes through straight microcontroller. So if we have no readings, that essentially means that here inside the microcontrollers we have a broken wire. So this blob consists of a silicon, a little tiny silicon wafer, and bunch of bonding wires which go from this to this, from this to this to this to this. So this PCB has tiny bonding wires connecting to the little silicon wafer here. Not wafer, little silicon chip, it's just bare chip right here, and then they apply this blob. If during the impact something happened to those teeny tiny bonding wires, we have an issue. So I'm gonna give it a one shot, one more, and gonna measure the voltages straight on those components which are leading to this microcontroller, and the voltages are there and there is no readings, so we have issue, and this thing essentially Gonski. Let me do that quickly. Gonna apply our battery. Okay, gonna start the thing. And I'm gonna measure millivolts again. Okay, that's connected. Would I? Oh, okay, I understand what's going on now. I understand. This is weird because what I'm doing right here, touching this resistor, this is essentially a fusible, like, I mean, it probably has to be fused here because it goes straight to VCC. Okay, so what I'm doing, I'm actually applying some tiny voltage right here, and it's doing something. But when I'm applying voltage right here, it does nothing. Okay, so the white one is busted. Yeah, clearly white one is busted. So white wire, this indicates, because it goes the whatever 9 volt goes through my finger and creates some millivoltage right here. So when I apply it to blue, it works, but when I apply it to white, it does nothing. And the white one is on that capacitor, like right. Nothing. Oops. Interesting. I did scratch a pod a bit, which leads straight to the micro. Okay, let me do this again. Do this and then touch that pod, and that pod is corresponds to the white one. Okay, no, nothing. Okay, so I finally found the good grips that can show you that right before this microchip right here, microcontroller, I measured 4.2 volt and there is nothing. That's really hard to do, but I'm trying. Okay, so here we are. So this is straight right before the traces entering the chip. We're measuring 4.2 volts. So yeah, so we clearly have problem within this chip. So nothing else I can do, I think, at this point. I see no any other active elements. There is nothing broken. I'm not sure what you're gonna do with this toy. Alright guys, yeah, like as I just showed, I think the problem is within the chip. It says broken bonding wire inside this chip. I don't know if it's possible. I don't have much of experience with this kind of cases, but there is no any other shorts. There is nothing, there is no falling, for example, components. I thought for a second there is one capacitor fallout, but because of the impact there is nothing. This is external memory, so yeah, nothing wrong with it for sure because it operates properly. And yeah, I'm not sure what we're gonna do with it because clearly the load cell itself seems to be fine, so I may just keep it for giggles and just to play around, you know. Yeah, actually what I found, this board can be actually interchangeable between different other kitchen scales, so I may just keep it around, you know, in case the screen will be busted or something like that. But the case, I may just ditch it because yeah, it's a plastic which I don't need, so it's gonna save some space, and this is gonna be sitting here like in this package. I'm gonna do something about it. Or I may just, for example, reuse this load cell, and with some other Arduino project, maybe we can make a Bluetooth, for example, a kitchen scale or Bluetooth scale, because I need scale around my bench sometime to measure weight of different things like light bulbs, LED lights, and things like that. It could be pretty useful. So, conclusion, it's irreparable. A positive side, we can recycle some of the elements. For example, there's a voltage regulator here, there is a battery terminal here. This memory probably, I'm not sure if it can be recycled because it could be, it's just write once memory, so it's written once and that's pretty much it. And yeah, and obviously load cell, as I just mentioned. The screen may be as a spare part for any other broken kitchen scale because this is purposely built device. So we're gonna just push it back like this. Hope it's gonna stick, and yeah, I'm gonna keep it around. Oh yeah, another one thing which I probably keep around, this nice plate. Maybe as a build, maybe reuse as build plate for 3D printer after I figure out how to dislodge this thing out of here. Yeah, this is kind of cool. I like it. Maybe it can be used for something else, for example, I don't know, for soldering jobs or for some insulation plate, you know, and things like that. I'm not sure what kind of epoxies they have used in order to, you know, secure it, but yeah, maybe also reuse these buttons, maybe. So yeah, this is it, guys. Thank you for watching. I think, I hope actually this was useful. It was clearly useful for me, and because I couldn't really fix it, I'm actually happy that I will be ditching these unwanted parts and keeping something that I can reuse later. So hope that was useful again, and if you like such videos, please like and subscribe. If you want to know more, please stay tuned for my future video. Stay safe and ciao.